We have a work function problem here, so let's first find the energy of the illuminating photons. So that's going to be hc over lambda. Okay? So we'll write in these constants. Everything's got to be in MKS units, so the wavelength is going to be 220 times 10 to the minus 9 meters. That's 220 nanometers. That's 9.04 times 10 to the minus 19 joules. And then if I convert that into EV, I get 5.65 EV. Okay, now our equation for the photoelectric effect says that the maximum kinetic energy of electrons is equal to the photon energy minus the work function. So the photon energy is 5.65 eV, and we've been told that the work function is 4.1. So that works out to be a difference of 1.55 eV. Now it would be in our interest to convert this back into joules. So my max kinetic energy is going to be 1/2 mv squared. That's going to be 1.55 eV. Now I'm going to convert that back into joules. Alright, and then I'm going to enter the mass of the electron. This is the kinetic energy of the electron. So there's the mass of an electron, and that's equal to 2.48 times 10 to the minus 19 joules. Right? So we got 1/2 mv squared is equal to that max kinetic energy. So if I solve for v squared, I get 5.44 times 10 to the 11th. Therefore, the velocity is 7.4 times 10 to the 5th meters per second. Alright, now for part B, the cutoff frequency. Well, the cutoff frequency where the electrons don't escape is the place where the electrons escape and have no kinetic energy left over, which means that the energy of the incident photons is exactly equal to the work function. Right, so that the photons escape, or the electrons, sorry, they escape, but they don't have any energy left over after they escape. So we set, we're looking for the frequency here, so I would set HF, that's the energy of a photon, equal to that work function, right? So let's see, I want 6.626 times 10 to the minus 34 times the frequency, and that's equal to the work function, which is 4.1 eV. But this side over here is an MKS, and this side over here needs to be an MKS, so I'm going to multiply by my conversion factor again. Alright, and if I do the math there and solve for the frequency, I get 9.9 times 10 to the 14th hertz.